welcome to Ladyada.
Hey everybody, and welcome to Ladyada. We are doing a Saturday evening broadcast instead of a Sunday, because tomorrow evening we're booked for some stuff. So we thought we would do a late night check-in tonight, see what's going on my desk. We've got all sorts of news and updates.
I have news and updates.
Do you want to give them the news and updates, and I'll do the electronics?
I do. Here's what we're doing. I have an update. Well, first let me say, what did we do this week? So on Tuesday, I think we mentioned that we were going to do some food bank stuff. So we volunteered at Feeding NYC. We have some stuff on our YouTube page and more. If you're interested in feedingnyc.org. I did turkeys and box demolition. There was 8,500 turkeys, I think, altogether.
Yeah.
And so those goes to all the homeless shelters around New York City. And then on Thursday, before we had some Thanksgiving dinner, Ladyada and I went to see a team member who was recovering from surgery in the hospital. And just a basket the team made. Here's Ladyada outside the place. And here's Roxanne. Roxanne's been with us for almost like 10 years. And we went and visited Roxanne. And our entire team sent their love and well wishes and more. So we did that, and then if you notice on the right-hand side...
Trader Joe snacks.
Yeah, if you notice on the right-hand side here, we have a PowerBook 180. So archive.org fixed the issue with the Prince floppy. There was a naming issue, so for the folks who tuned in last week, this is fixed, so you can go to archive.org and just search for Prince floppy, and you'll be able to see this disk that we recovered the data off of, and Neil Dash had one, and this is when Prince changed his name to the artist formerly known as Prince, and he had this cool symbol on it. There's a TIFF, a real neat story behind it, and more. So that's the news for this week. And then today, I got a chance to work with the team, and we got a bunch of orders out. Thank you, everyone. Adafruit was pretty quiet for some of the manufacturing, but we were still doing lots of stuff. Big rounds of receiving and pallets came in. Puppet's there to help, and here's my just got finished shipping running around selfie. That's mandatory nowadays. So we'll take it away, Ladyada. What's going on this week?
Okay, so this week we it's been both a short week and a long week. Short week because of course we were closed on Thursday, and yesterday a lot of people took the day off. But also meant I got some time to really sit down and work on some prototypes that I've been meaning to wrap up. So I worked on the ESP32-S2 QT Py. Let's go to the overhead and I can show it off.
All right. Let me get it to overhead mode.
So we've got, historically the SAMD21 version and the RP2040. These are both based off of the Seed Shao pinout. They made this board called the Shao with the SAMD21. And I thought it was really cute, but it was just missing, a STEMMA QT connector that would let it plug into many sensors and displays and other I2C devices. We just love these little plug-and-play cables that's, SparkFun came up with. So this is actually kind of interesting. It's like a merging of a Seed board design and a SparkFun standard for I2C sensors. But we see good ideas, and we're like, let's use them. That's my policy. So having done a SAMD21, which is good, and then when the RP2040 came out, we made a double-sided version that's like nice and powerful with the new RP2040. I thought it'd be cool to make a version with the ESP32-S2, which is the ESP32 chip that has native USB and Wi-Fi. So it's it would be a nice little upgrade. It's like Cortex M0, like dual core Cortex M0, like high speed. CircuitPython runs really well on this one. And then the ESP32-S2 would make a great board. And then, of course, the S3, when they have chips available, I'll respin this design for the S3 as well. So the S2, what I was waiting for is this particular chip, which actually ended up de-soldering from a module, is the ESP32-S2 R4N2, or maybe it's the N4R2. It's one or the other. And it's the version that has built-in 4 megabytes of flash and 2 megabytes of PSRAM. And you really want that PSRAM. Like, I designed this board before the PSRAM version chip was available. And I didn't release it because it's like, until you have PSRAM, it's like this chip is not... In CircuitPython, it's not that usable. Like, you can do some things, but it's really, really hard because the internal memory is only like 300 or 400K or 500K. And that's a lot of RAM, but like the minute you do SSL and you're like getting JSON data from the internet, you run through it very quickly. And so thankfully there's now this version, like I said, which has, this chip has the flash and RAM into it. It's a package that's bonded inside. So that's really neat. I really like that Espresso did that because it means that, I can make this this design here, which is double-sided, yes, because I really want to have that Stomach QT connector and the 2 buttons, and then before you know it, there's really no space for a chip on the top. So I'd rather just do double-sided. So there's the ESP32-S2, 0402 capacitors and resistors and the crystal and all that stuff. And then you can see this little opened up area. This is where the antenna comes out on the other side through the board to make the antenna, launch antenna. And we actually covered this antenna on the Great Search a few months ago. It's a 2.4 gigahertz mini antenna. We use this on the Circuit Playground Bluefruit. It's a perfectly fine antenna and works nicely enough. And then on the top we got a NeoPixel boot and reset, and then Stomach QT connector. So this is actually set up to be a demo with Adafruit I/O. Let's see if I can get this demo up and running. So you've got here, an I2C OLED. It's connecting to Adafruit I/O, and it's writing temperature and humidity data. And then if I go to the computer, I've got here the dashboard that is showing the data being sent. And then if I hit this button, you can see here this, this reacts to the button press. So that's how I know it's working nicely. Humidity temperature data transmitting just fine. So this is a good demo because it's Wi-Fi, it's SSL, it's sending data very quickly. So it's a good test. Now, the antenna is not super powerful, but I'll show I have another option for those who want it. So the next thing that we have to do is do the silkscreen design, and Phil B does our silkscreen design. So this is kind of what he came up with. Nice. He exports the Gerbers and then draws them in Illustrator. He has a 1-minute video that he's done on the process, and then he posted this. And I was, the top is sort of standard. It's very similar to the other ones. And the bottom, it's mostly like a game of what can you fit where. This version, because I figured some people might want to run this off a battery, I put a little battery input pads on the bottom. So tried to stick with that, Xiao pinout, but not, but still add more capability. And then we chatted and we were like, okay, let's just change the Adafruit, logo a little bit. But then, I'm basically going to take the silkscreen, import the bitmap into EagleCAD, and then export it to, the Gerber files to send off. And what's interesting about this design is I'm going with a 4-layer design, which I've never done before. Usually I would do a 2-layer. And if I'm using something like a module, like an ESP32 module, I will do a 2-layer design because the module itself has a ground plane. But because I'm using the chip here, and the prototype is a 2-layer, but because it's a chip and there's no, the ground plane is really cut up by all the components. Like even if you have ground on both sides, it's never quite enough. And, there's not a lot of capacitance on the board because I can only fit 2 or 3 big caps on the 3.3 volt line, and you really need a lot of capacitance to deal with the Wi-Fi signal. I actually designed this as a 4-layer board, and I try not to do 4-layer boards because they're more expensive and they take longer. There's just more risk with them, but this board is really small, so I don't think the cost is going to be very much, and I don't think it's going to increase the time it's going to take to make PCBs. Maybe I'll take a week instead of 3 days or whatever, which is still fine, and I think it's worth it because, again, it's a chip, not a module. The module has its own ground plane, and the chip, of course, is just a chip, so you have to provide your own. So layer 2 is ground, layer 3 is 3.3 volts, and I have signal on top and bottom. And there's still a little bit of a ground plane, but as much as possible, I punch through into the inner layer. So it's going to be really exciting because I've never done a 4-layer board order, but I think this is a good one to do it with.
All right.
Any questions?
No, I would just say that folks were wondering how the double-sided would be, so quite dense. And
it is
then,
quite
yes,
dense.
It is the new QT Py.
Yeah, it's dense, but I like to I kind of like to fit everything that makes sense to fit in, and I think having the 2 buttons and the USB-C and the STEMMA QT connector especially is quite large. I mean, it's a very small connector, but it's large compared to a lot of components. So it's double-sided, but I find that first off, you could always have a cutout if you're doing castellated pads, but a lot of people aren't using the castellated pads, to be honest. A lot of people they're happy to solder it in with headers, and of course there's header pads. So the only thing is, the antenna is kind of small. So I made an alternate version. Let's go back to the overhead.
Sure.
And this version has a UFL connector. And so we stock in the shop these little UFL to Wi-Fi antenna thingies. And let's see if I can unplug this.
I have other questions.
Yeah, go for questions.
Okay, I can do this one. Does this have to be FCC certified? No, because it's a prototyping board. But if you need to use it in something, you should make sure you work with an expert who will talk to you about certification.
Yes, if you put in a product, you have to certify it. This is a development board. I probably will try to get this FCC certified eventually, but it's not
we
going
do
to be
FCC certification. You can look at some of our boards. Next up, how much, if any, do you use the auto router?
I'd not use the auto router for this. I always work by hand. I don't even know if there's an auto router in EagleCAD anymore anyways.
I don't know either.
Yeah. Okay, anything else?
No, folks seem to like the board.
Okay, great.
What's next?
Okay, so just showing, if we go to the overhead, the computer,
Okay.
I can show that, with the antenna, I can see Adafruit's the local, I'll move this to the side. No, it didn't move. I'm getting, 50, negative 50, the smaller the number, the larger the number, negative, the better. And so, my Spectrum Wi-Fi, I think that's our local Wi-Fi hotspot, that's 55. This is pretty good. I think, if you always use a bigger antenna if you really want better signal, but I think this is okay. And I think also, again, when I update this to be 4-layer, that might help a little bit too. But, you can always revise it. So I'm going to send out these PCBs. But I thought I would do the Great Search because I thought actually people might be interested in UFL connectors.
Where in the world is that part I need? The Great Search with Digi-Key.
All right, the Great Search brought to you by Digi-Key and Adafruit. Every single week, Ladyada uses all of her powers of engineering to show you how to search for things on Digi-Key.com. Thank you, Digi-Key. What is the Great Search this week, Ladyada?
Okay, so this week we're doing a UFL connector. So let's go to the overhead real fast, and I'll show it off because it's small. So for this design, I have a version that has a little mini 2.4 gigahertz antenna. And it's a very small antenna. And it's it's okay. Like these are really cute little antennas from Johansson. But if you want a bigger antenna, you can always go with the UFL connector. Now there's not space for both, but I can make 2 versions of the board, one of each. So this version has a UFL connector, and UFL connectors are, I think technically they're micro FL. I think the U is micro, but I call them UFLs. So these are a standard connector type. This is what the bottom looks like, and then on the top it's got this little ring, and inside is the center. And these are really good for, I think, up to 6 gigahertz. They're extremely small. They're extremely common. They're good for maybe 50 up to 50, 10 to 50 reconnections. Now you're not meant to unplug and plug them, but you can do 50 reconnects with them. And then you can get this is a little antenna that has a UFL connector already on it. There's also UFL to SMA connectors. Maybe I'll try to find those as well. But these are really common, and they're well understood. Like when you see these, people are like, I know what that is. That's an RF connector. So you'll see these a lot on dev boards. We use them a lot on dev boards, but you'll also see them on other dev boards. And also sometimes you'll see modules that have UFL connectors. That said, they don't have strain relief. So, one of the things you have to watch out for is if you do use them, unlike SMA where there's like a screw type things in and, you can keep it from yanking out. There's really, these parts, you can snap the antenna in and it is a little bit, it's a little bit solid and it can twist, but they pop out pretty easily too. So just keep that in mind, that if you want to have something with UFL, like it can rip off fairly easily. It's not a through-hole connector, it's purely SMT. Okay, so let's go to, I'll show you, there's a lot of options available. So yeah, they're called UFL, so small UFL connector, and they're going to be under RF connectors. Oh, you know what? I think you have to do U.FL. That's the technical name for them. I usually leave the dot out, but usually you normally would. So you can see there's connectors and cable assemblies. Let's just check out cable assemblies really fast so you can see. You can get UFL to like anything adapters. So that's another thing. Oftentimes you don't have space for like MMCX or SMA or whatever, but you can get connectors of adapters of all sorts. So you see these are very standard. You see pigtails, so you can connect your own things. UFL to UFL, so quite nice. I guess they're sometimes called UMCC as well. That's another name for them. So if you do want to get an adapter, check out here, and then you can pick B and C if you want for the other side. Okay, great. So that said, back at connectors, we can see that these are actually kind of like immediately it pops up. So I don't think this is, I guess this is a through-hole version, which I've never seen before. But you want UFL series. So let's look for active, UFL. These all look fine. I think gigahertz. We want 3 to 9 gigahertz. I will say, something changed with the Digi-Key search, by the way. If you select things now, it will. If it changes what's available, you'll see, like, because I selected through hole, a lot of the options are no longer available. So it shows you what else got filtered out. So this is new because this wasn't here like last week because I use Digi-Key search like every week. But it is nice to see, like, without having to filter, you can quickly see, like, what are you going to lose out of. So if you have multiple things that you're searching for, that can help. So let's do the surface mount. And yeah, lots of options. So, you can sort by price. These are, they're pennies pretty much. The first one that came up that looked fine to me was this from TE Connectivity. They make good connectors. They have, 150,000 in stock, so you don't have to worry about not being able to get these. Not affected by a silicon shortage, but there are also other vendors available. The only thing I'll make a note of, the last thing to mention with UFL connectors before we get back to questions is there isn't a photo of the bottom, but let me see. I think we took a photo of the bottom. No, we didn't. So on the bottom, there's 2 contacts, but only one of them actually feeds through. And just remember when you do your footprint for that, to make sure you don't accidentally get the part rotated because it looks like it's symmetric, but it's actually not. On the bottom, there's only one pad that feeds into the antenna input. And if you get that wrong, as I have before, you have to rework all your boards because the antenna isn't going in. So if you do use these, one of the tests you might want to do is when you're doing the assembly test, because it's, again, visually you can't tell that it's wrong. Have someone plug in an antenna and check the RSSI, the signal strength, to make sure that they didn't flip it around 180. That's a tip for you from someone who's made this mistake before.
I am.
Yep. All right, any...
And that's a great search. Let's do questions. So
Yes.
let me roll the outro.
Where in the world is that part I need? The great search with Digi-Key.
All right, so here's some questions. will this support? This is a board you showed before. BLE and CircuitPython and or Arduino.
This will support Arduino and CircuitPython. It does already. It doesn't have BLE because the chip doesn't have BLE. But the S3 chip, which is like slowly coming out, might be a drop-in replacement. So when that's available and has PSRAM, that does have BLE support.
Okay. Tiger Bright says, "Yay! You fell on Adafruit board. I really like the particle feather boards for my longer range Wi-Fi Bluetooth stuff because of their external antenna capabilities."
Yes.
Okay.
Exactly.
And then next up, what's the nominal range for the non-UFL?
It's hard to tell because it depends on what's on the other side, but I think it should still be like at least 50 feet from the access point. I mean, I have to compare it with the feather with a built-in antenna to check the RSSI, which it's affected by a lot of things. But the signal doesn't seem too bad. It seems about what I would get with maybe it's half as much as a PCB trace antenna. But it's much, much smaller, right? That's the thing. It's a very small antenna.
Okay. And I think that is going to be it.
Okay.
Ladyada.
All right, great. We got through everything. All right, well, have a great weekend.
Right before the finish line. Any idea of the power draw in deep sleep?
It's going to be about 100 microamps,
Okay.
which is kind of what the ESP32-S2 does in sleep. It's
Oh.
70, 80, 100.
One more question, and then you know what? I have to remember. We're supposed to do things like tell people to buy stuff.
It's a sale.
Well, if they want to. How's the NRF 52840 availability going forward? Do you know?
I mean, Nordic only has one job, and that's to make sure that there's NRF 52840s. I know that their chips are used in like Apple AirTags and watches and stuff. So there is there's a lot of demand, but I think it seems to be okay. Like we've been able to get NRF 52840s. It's SAMDs and STMs that are like really challenging right now.
All right. And then any plans for a tricolor mag tag? Can I use a 3-color screen on mine?
Yeah, you can just swap it out.
Yeah, you can
We
swap
don't have
it
a
out.
plan. We don't have a plan, but the reason why, it's a good reason, it takes a lot longer to refresh tricolor, and so your battery is on the entire time, and we didn't want to, we thought it would reduce the lifetime, because people want to have it on for a long time, so we decided to go with grayscale, because it refreshes in like a second.
Yeah. Okay.
Reasons.
I think that is it.
Okay, great.
Oh, someone said, "What's the voice behind the camera?" That's me.
It's us.
Hello. That's the voice behind the camera.
Okay, that's the person behind the camera. Also the person who did the shipping today.
Did some shipping, and then I did a bunch of stuff for you, and then I did a bunch of stuff for a bunch of different departments because I'm here to serve and help. That's my job. That's
true.
the desk of Ladyada. We'll be here all week during the week. We've got shows on, I think, starting back
we
up
got
on
Wednesday.
Yeah, for sure Wednesday is show and tell and ask an engineer, and then
No,
Thursday
Pedro
no
might
and
be
Pedro I
back.
believe are back, and
I
then
think Scott's back too.
Scott's back, and then also JP I think is back towards the end of the week.
People are going to be back, and they're going to go again, and they'll be back again.
So have a
it's winter.
happy, safe rest of holiday, and thank you everyone. Oh, can you go to adafruit.com, Lamar? I gotta remember.
Yeah.
Whoops. So we have a sale going on right now, and basically it's fun to put stuff in your cart because you can get free stuff. Now we only have a few more pink feathers left, so do you want to go to /free? Adafruit.com/free?
Yeah, hold on. What's it? So much stuff going on.
Yeah, /free.
Okay.
Okay, so you get a pink feather.
But we're running out.
We're going to be out in like
We were only
minutes.
going to do it for Friday, and we had enough to kind of get us through Saturday.
And then,
I have more PCBs on order, but it's like they're taking forever.
so we're going to give away a black feather. Like a crow. Go to adafruit.com and check out the sale. Use the code ADATY. Thank you. To get 15% all items in stock. And you get all the freebies and a bunch of other stuff.
Except gift certificates.
Except gift certificates and whatever
and
things.
software.
Well, of course, that's.
But pretty much everything, like 99.9%.
And we don't do back orders, so anything you order
ship.
will arrive.
We actually have it. We do not take back orders. If it says it's in stock, it is literally in stock. Like it's on a shelf in New York City.
All right. Thank you so much. Yes. Someone put a funny man behind the curtain Wizard of Oz thing. Yeah, maybe it's
There is a
like
green
that.
screen, so yes.
There is a green screen.
This is the Emerald City.
All right. Well, thank you, everybody. We'll see everybody next week. That is just Ladyada.
Bye, everybody.